All right, here we go. We are live. Let me make sure this mic is working. I always tend to check after we get one. All right. We are live. All right, so everything you're saying right now, I can hear, and the microphone can pick up. So that's your warning for the year about language.
Did they make you take your lights down?
No, I took them down because it's not Christmas time anymore, and I'm not crazy.
Okay.
For those of you that still have your Christmas trees up, shame on it.
No, I don't have a Christmas tree at all.
I keep Christmas lights up.
That's the best kind of Christmas tree.
I'm getting
Not having one at all.
As the person who has to put them all up and take them all down, that's I mean, if you're the one putting it up and taking it down and you like it, that seems to make sense to me. All right. All right, nerds. Here we go. So today we're going to be talking about some trigonometry. Trigonometry. No, it's not, and you're going to find that out today. So trig starts with tri. Gabe, what word do we know that starts with the word tri?
Try.
Thank you, Gabe.
Wait, what? Oh.
Correct, Perkins. Triangle. So gonometry. Really, nometry means the naming or identifying.
So it'd be like, do it.
Identifying and naming triangles, yes. So we're going to be able to figure out stuff about triangles using some special stuff. We have done stuff like this, right? It's really not that big of a deal. There's going to be something that's a little bit different today that you may or may not have seen before, but in general, it's not that bad. We're going to be talking about the angles of triangles and how it relates to their sides.
So what's just the inspiration of the name?
The inspiration for the name? What are you talking about?
Like, it's like, yeah, go, do it.
Yeah, trigonometry. Try it. Give it a chance.
Try some.
Give it a chance. Give it a chance.
Try some trigonometry.
So trigonometry really only works for right triangles. I mean, there are ways to make it work for things that aren't right triangles, but in general, right triangles are the thing we like. And here's how it's going to work. Okay, do not freak out on me. I'm going to show you guys a new symbol. This is a Greek symbol. Okay, here it is. It's this little circle, and it's got a squiggly, kind of like the Pepsi sign, right? This is called theta. We call this symbol theta. And theta is just a symbol like X or Y or anything, but it's special. Like X can be any number, right? It's used all the time for whatever. Theta is almost always used when we're talking about angle.
Okay, so it's an overcomplicated X.
It's an overcomplicated X. The only thing it helps with, that kind of makes it work out, is that whenever you see theta, you know they're talking about an angle. We're talking degrees probably, right? That's all that's for. So what that stands for is the angle measure right here. That's it. What is it? We don't know. It's a variable. That's all. Now, theta was my Sunday school teacher. She taught me things about the Lord. So that's how I remember theta. She was this very old woman. She's still alive, I think. Shout out to Theta. Theta is her real name. She lives over in Plano. But that's her. You did? No way. No way. She's so sweet. She's like Mrs. Loudermilk, but maybe less sassy. So just like all love and goodness.
Wait, Plano?
Plano, Illinois.
Yeah, I lived there.
Nice.
Yeah,
I did too. It was a time.
It was a
I
time.
the teacher's name except for Mr. Smith because he's the one I actually like.
Gotcha.
Last time.
Well, theta is wonderful. Anyway, so here we are. Theta talks about the angle. And what's cool is that this angle right here opens up to this side. So we're going to call that side the opposite side of this angle. Opposite. Is everybody cool with that? This side right here being the opposite side of this angle. Opposite.
Oh, yeah.
Right? It's a cross. You do remember something about Cheeks theory. This is good. This is good. Welcome to 2019, everybody. All right, so that's the opposite side. We're going to call this side right here the adjacent side. Adjacent. And the word adjacent just means next to. Like, for instance, adjacent to Kenny is our new student who we've never met before, Tyler Perkins. They are adjacent to each other. They're right next to each other. Whereas opposite of Kenny, sort of, is that big, right? So opposite of Kenny. Kenny is theta in this example, right? He is theta. He is the angle. Opposite is Abby, and adjacent. Perfect. Now, Angel. Alfredo's not here. Alfredo would be over here with the adjacent. Angel is over here. He is the hypotenuse in this situation. He's the farthest away from this guy. He's sort of kind of like opposite, but not really. Just here he is.
He exists.
He exists. He's a big deal. He is the biggest side, and he's opposite the 90-degree angle. This is the hypotenuse, and we know this from Cheek's theory, right? Hypotenuse. So we've got 3 sides to a triangle. That's what the triangle means, right? 3 sides, or really 3 angles, right? We've got opposite, adjacent, and hypotenuse sides. That's it. So before we go any further, I want you guys to identify these triangles. If you want to get some graph paper and do this on your own, I would highly encourage you to practice this. I'm going to give you 3 examples, and we're going to go through and label each side. So again, here's your example. Remember, the hypotenuse is the one opposite the 90-degree angle. The opposite side is the one opposite theta, right? And the adjacent is the one that's attached to it. That isn't the hypotenuse. Say it again? Pretty much, yeah. It should sound familiar. All right, so I'm going to give you 3 examples. Example number 1. Here's a right triangle. It's not a very good triangle, but there it is. And I'm going to give you that this is theta. So that's where theta is, that angle right here. And I want you to label all 3 sides. You can label them A for adjacent, O for opposite, O, and H for hypotenuse. If you want to, instead of using O, you could also do OP, because O kind of looks like 0. So we've got H, O, and A, and we're going to label our sides. So given that this angle is theta, first find out which side's the opposite, right? Or maybe if you think, oh, I know where the hypotenuse is, that one's the easiest to find. Put that one down first. The adjacent's always the weird one, in my perspective. I like writing down the opposite and hypotenuse first. Here's your example up top. Here's your problem down here. If you're bored with that one, you think that's pretty easy? Here's this. I'm going to tell you that theta is this angle down here, and you can label everything. This one's kind of a brain buster. Try to label the sides. Opposite, hypotenuse, and adjacent. What a start to the new year, everybody. Perkins does need some. But he's new, he doesn't know. Kenny, you gotta help him out. Perkins is your responsibility, just like Abby, Kenny is your responsibility. Let's go. Already got it. Here you are. Nice job. Hey. The biggest side is always the hypotenuse. Yes, it's the one opposite the 90 degrees.
It's going to be awkward, but it's going to be there. Because you're not able to name.
Remember, the hypotenuse is only something that happens when we have right angle triangles. So you said no.
I thought I had that one. Well, it looks like somebody murdered somebody that's like,
So, is that right? Texted you and you're just like, oh, we're talking to you again. This is you, Abby. Yeah, that one's weird. Yeah. Yep. Yes. 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 Although technically there is an opposite side.
You're gonna like twist. Oh yeah.
Number 2 is supposed to mess with you. If you're confused about that, you should be. Number 1, hopefully not. Give you a couple more seconds to figure it out.
Wait.
Kenny, I'm going to move you if you can't focus over here. Prove it. Words are meaningless to me. Prove it.
So basically just label it.
Don't worry about number 2 if you've got number 1. It's a good life lesson right there. What? Yeah. Okay, doing all right?
No.
All right, so let's label our sides. So, what is this side going to be called?
Opposite.
The opposite. OPP. Opposite. Why is it the opposite, Mr. Perkins?
Because it's the opposite
Of the, not the right angle.
the
Theta, yeah. Theta. Shout out to theta. All right, so the opposite of theta, which is like, I don't know, evil theta. I cannot imagine an evil version of this person, but is over here. That's the opposite side.
This is an adorable lady.
She is. I'll find you a picture of her. She's just very, very nice. Like, imagine Sunday school teacher with glasses. That is theta.
I hope we're thinking of the same person.
We've got to
She
be.
was like, she was a hard teacher.
Really? I mean, she taught me well.
She was, yeah.
Yeah.
No,
She the one that-
No, that might have been my dad. What?
What's her last name?
McMillan, I think. Yeah, something like that. Or McManus. Yeah, I can't remember. It's been a long time since I've talked to her. But she is wonderful. All right. So yes, the opposite right here. The opposite side is opposite theta. It's directly across from theta. What's directly across from the 90 degree? The hypotenuse. Yes, that one, right? I don't know. I just make up words sometimes. That's literally how I teach. All right. So we have the hypotenuse and the opposite. So which one are we missing? Adjacent, the last one, which must be this side here. And it makes sense because it is attached to this angle, right? It is adjacent. So this is our adjacent side. So as you can tell, depending on where theta is, things change, right? Adjacent was down here, and now it's over here. It's because the angle that I've chosen to call theta is in a different spot. So you have to look at that angle. We call that angle a reference angle because you have to reference it to figure out what sides are what. Now check out this. We've got this theta right here, and across from theta should be the opposite side, right? So that's our opposite. But that's also across from the 90 degree. So it's also the hypotenuse.
Oh, that's nice.
Oh, that's weird. That's weird.
That's what I think.
What must these sides be then? The adjacents.
They're both?
They're both adjacent. This is weird, and we almost never see this. You know why? Because we don't need to know what theta is in this situation. What is theta here? It's 90, right? So it's kind of silly to be like, oh yeah, what angle is that? And they literally just told you, right? So we never see this. Here are our two options. We've got theta in the bottom right with opposite in the top left. And we've got theta up top with opposite in the bottom. Really our two options. That's it. So now that we know that, we're going to do some cool things, okay? We've talked about ratios earlier for our warm-up. Ratios and proportions. A ratio is when we have something like, I don't know, x over y equals a over b. Remember we did that for our warm-up? We had two things equaling another two things, right, in comparison. There's a special relationship between these sides, between hypotenuse and the opposite, the adjacent and the hypotenuse, and the opposite and adjacent to this angle. So on one side, we're going to have theta. And the other side, we're going to relate it. It's not going to be equal, but we're going to relate it to, maybe, I don't know, the hypotenuse over the adjacent. And that's how things are going to work. So if I told you that the adjacent was 2, and this side here was 3, 3 over 2 would be our angle. There's a relationship there. And we have to do something special to this angle, this theta. We have to do something to it in order for this to work out. Because your angle's not just going to be 3 over 2, right? What is that, right? 3/2 of an angle, a degree, what is that? We have to do something special. What we have to do is we have to use a trigonometric function on it. And that's a big fancy word for something like this. Sine cosine, and tangent. Who's ever heard of these? I know you've heard of tangent. We talked about tangent with circles, right? The circle just kind of kisses the line. It's like one point where the line touches the circle. Have you ever heard of these guys? Sine, cosine, and tangent.
What's the foreign language? I don't think so.
It's Greek, and it's okay.
So I don't speak it. Yeah.
You don't need to translate it. It's kind of like a name, right? If I were to go to Mexico, my name would still be Derek, right? It just would. Or maybe Senor Mac if you want to really like translate it. But in general, your name stays the same. It doesn't change. I know it's fun to do like a Spanish version of your name and all that stuff, but in general, your name is your name. It doesn't change no matter what language you're saying. Italian, Greek, these are names. So you don't have to be like, oh man, what does sine translate to? What's the conjugation? And do Spanish. You don't need to do that. Sine is just a thing.
Or I don't think you can say Derek.
Here's the definition of sine. Okay? Here's the definition. Sine equals opposite over hypotenuse. So if I ask you the sine of that angle, what's the sine of that angle? I'm not talking about astrology, okay? Oh, it's a Libra. No. The sine is the opposite over the hypotenuse. So I'm going to draw you a triangle. Here's the triangle. And here's theta. There she is. This is a right angle. And I'm going to tell you, whoops, I know, I'm losing everything, that this is 3, this is 4, and this is 5. So what's the sine of this angle? What's the sine of this angle? What's the opposite of this angle? 3. What's the hypotenuse, Kenny? 5. So the sine of theta, the sine, we write sin theta, she would never commit a sin, is 3 over 5. Sine is the shorthand, or sin is the shorthand for sine. Got to save that one letter. Don't have to write that. You know. So sine of theta, the sine of that angle, is 3 over 5. Okay. How you feel? I'm going to give you another example. Take a good look. Gabe, you're going to help me on this one. The sine is the opposite over the hypotenuse.
Yeah.
Okay. Here's a triangle.
You know those really weird ones on the slide.
Here's a triangle. 5, 6, 7. I want to know if this is theta.
Oh, okay.
What's the sine of theta? It's the opposite over the hypotenuse. So what's the opposite?
The opposite of wait. Oh, wait, you're talking just 5.
Yeah, it's 5, right?
It's 5 and then your hypotenuse is 7.
Exactly. So the sine of this theta is 5 over 7. Now what if I said, oh, no. I'm sorry. I made a mistake. What if I said that's theta?
Then it's
6 over 7.
Then it's 6 over 7 because now that's the opposite side. Nice job, Gabe. Nice job.
Wait, why do we have the adjacent side?
Why did I give you the adjacent? Just for fun. All triangles have 3 sides, so I might as well leave it, right? Also, I was trying to throw a curveball. Maybe you'd say 5 over 7 for this one.
Put all the extra work to figure out.
I wrote a whole extra number over there. Morgan, thank you. You are my efficiency expert.
Is that a real triangle?
No, it was not actually. All right, so good question. Sine is opposite over hypotenuse. Okay, cool. So what's cosine, you're asking? I know, you want to know. The people need to know.
Don't want to.
They need to know. Oh, they want to know. They want to know. Listen to them, YouTube. Listen to them. They're begging. What is cosine, Mr. Mac? I must know. The sine has something in common with the cosine, which makes sense because they kind of like the same word. Cosine's like the co-pilot, right? They also have hypotenuse in the bottom. What do you think is going to go on top? Adjacent. We already used opposite, right? So the cosine is the adjacent over the hypotenuse.
Oh, is that a new thing?
Yes, cosine is a new thing. It's very similar to sine,
Okay.
but slightly different. It's got adjacent on top. So
It has a code in front of it.
it does. So here's the angle, theta. We said the sine of this angle is 3 over 5, right?
Yeah.
What's the cosine of this angle? The cosine is the adjacent over the hypotenuse. It is 4 over 5. because it's the adjacent over the hypotenuse. Is this hard? It can be if you don't know what it is, right? If I didn't tell you what cosine was, you'd be like, I have no clue, right? But if you know what it is it difficult? No, so you need to know it, right? Easy points. All right, so we just learned cosine in like 2 seconds, right? I'm going to teach you tangent. Tangent. Morgan, do you have a prediction for what tangent will be? There's 2 things it could possibly be. Take a stab at it. It's a 50-50 chance. You don't want to? All right. What do you think? We've already used opposite over hypotenuse. We've done adjacent over hypotenuse. Opposite over adjacent is correct. You could have also said adjacent over opposite, but that's something different. Opposite over adjacent. So, Mr. Perkins, our newest student. In this triangle, here's theta. What is the tangent of this theta? It's the opposite over the adjacent. 3. Adjacent is? Oh, try again. 4. 5 is actually the what? The hypotenuse. The hypotenuse. Don't get them goofy. Common mistake. So notice that sine and cosine both have a 5 on the bottom because they both use hypotenuse on the bottom. Tangent is very similar to sine. It's got opposite on top, but it's got adjacent on the bottom. There's an easy way to remember this, okay? Which one goes with which? There's an easy way. You want to know it? You want to know it. You want to. The people demand it. All right, so there's this little acronym mnemonic thing. Mnemonic is a fun word. So sine starts with an S, right? And what is sine? It's the what over the what? Opposite over the hypotenuse. Cool. And what is cosine start with? C. And cosine is what over what? Adjacent over hypotenuse. And tangent starts with what? What does tangent start with? T to T. And it is what? Opposite to target. All right, so check it out. Check it out. We've got so, that's sine, ka, that's cosine, and toa, that is tangent. So SOHCAHTOA.
Where have I heard that?
I don't know. You probably heard it on a TV show or something. It's a pretty popular math thing. SOHCAHTOA. It helps you remember.
I've heard that before.
You have?
SOHCAHTOA.
So sine of theta equals blank, and cosine of theta equals blank, and tangent of theta equals blank.
Every single row I put in anything with that symbol and it shows a math error.
Whoa, that would anger me deeply. All right, so sine of theta is what? It's the what over the what? The opposite over the hypotenuse, because so, ka tells us that cosine is the what over the what? Adjacent over the hypotenuse. Is everybody with me? Kind of. And then toa tells us that tangent is what, Gabe? Tangent is going to be the what over the what?
Oh, yeah, the opposite over adjacent.
Very good, the opposite of the adjacent.
I'm just not going to remember that.
SOHCAHTOA. That's your job to remember it.
Yeah.
SOHCAHTOA. SOHCAHTOA. It sounds like the like another name that could have been for the volcano in Finding Nemo instead of Wanahakalui. It could have been SOHCAHTOA.
You know what?
You remember that name?
You know what it is?
Sad that I don't remember.
I am a fiend at Disney trivia at Thanksgiving.
It's that one SpongeBob episode where Squidward screams,
Oh, Krakatoa.
Krakatoa.
Krakatoa, and then his head explodes. Yeah. What was his superhero name? What was Squidward's superhero name? Was it like
what
his
was it?
superhero name? When he's like, is it Krakatoa? Is that his?
Yeah, I think so.
I got a phone, I'm looking that up.
All right, do that right now, Gabe. This is important. This is important. Yes.
That was
Because you have the quickster, right? That's SpongeBob. He's just really, really quick. You want to see me run to that tree back?
You want to see him do it again?
Right? What is Squidward's name? What is Squidward's name?
Krakatoa. Sorry.
Let us wait in silence.
Squidward superhero name.
I was just like,
What is it?
I'm gonna go right now.
Captain Magma.
Captain Magma. All right. So Captain Magma says Krakatoa. You need to remember Sokotoa.
okay.
It's so similar.
I
All
don't know
right.
why. Never mind.
So here's Sine.
Sorry, I brought that up.
No, please don't be. I am all for SpongeBob references. It is one of the greatest shows of the 21st century.
Yeah? Yes.
Although I think it originally came out in 1999. So.
Yes.
All right, so 99 was a good year. Here's your 3. If you want to take a picture, now would be the time to do it.
I wouldn't know. I was born 2 years
That would be a
after.
thing to take a picture of, although Mr. Perkins is already writing down notes like a champ.
Isn't that sad?
I didn't hear what you were saying, but yes.
I was born 2 years after, so I wouldn't know.
Oh, okay. So, here's what I want you to do. Using this information,
Ooh,
here's your triangle.
there's the triangle.
Here's theta. And I want you to label the sine of theta and tell me what it equals. The cosine of theta and tell me what it equals. And the tangent of theta and tell me what it equals. Can you do it right now, as is?
Possibly.
What are we missing? We need side lengths, right? We need side lengths. So I'm going to give some side lengths. How about, let's do 6, 8, and 10. Do that now. Tell me what the sine of theta is, the cosine of theta is, and the tangent of theta is.
Oh wait, I don't. Oh, I'm gonna get the whole name.
Wow. What a comeback.
Okay.
Top 10 comebacks of 2019.
The one that you say 2019, I'm like, oh, this is a meme, and I'm like, oh wait, no, this is actually.
Wait, is there a squiggly line? Or is it just
It's quickly.
Did you say it was like this?
Yeah, the official symbol looks something like this. I'll do it in the board so Morgan can't see it. Just kind of teach her in. Circles with little squigglies, kind of like a Pepsi symbol.
Yeah, that's what I did.
Yeah.
I don't know what the Pepsi symbol looks like.
Good for you.
You don't know what Baptist looks like? Or are you strong?
Well, no, because I don't drink pop and I don't look at it. What about that Baptist mean? I'm sorry.
I apologize.
How's it going?
What?
If you're gonna take my pen, you gotta use it. Come on.
Well, if you get to that, you just
I don't have this knowledge.
Pandora bracelet. Nice. Are you gonna become a collector? Oh, charm. Don't do it. Don't go down that rabbit hole. Don't go there, sister. All right. He's Perkins is bored. He even simplified his fractions just for fun.
He comes from a class that they probably had to.
Yeah, you know me. Never simplify your fractions.
Just saying.
I want the most convoluted fractions you can give me.
Yeah, well, if we want to immediately. I can't really read the yellow.
Right. You should probably start out with.
Yellow says Picasso.
My concern is definitely. I will agree. My concern is definitely not whether we can simplify the fractions. Cosine. Cos.
Sorry.
The abbreviation for cosine, and tan is tangent.
Trust me, it's going to be a work of art. It's a big deal. They're gonna be looking
And
at
yes, there are all kinds of math jokes. Tan.
Ow.
All right, time's up.
No,
I've given you
what?
plenty.
I need to write it down.
I completed some.
Welcome to 2019, kids. We got to move faster, and by faster I mean we have to move at a pace. I think some of you guys haven't done anything since I gave you this little assignment. So, somebody help me. Sine is opposite over hypotenuse. Alex, what is our opposite value? Opposite of theta is, nope, hold on. Opposite is 8, right? Yeah. And then over 10 because 10 is the hypotenuse, right? So 8 over 10, which Mr. Perkins knows simplifies to 4 over 5. That's right. Same thing. Either or is acceptable to me. Cosine is what over the what? It's the adjacent over the hypotenuse. Which is our adjacent side, Morgan? 6 is the adjacent, and the hypotenuse is 10. These two should match because they both have hypotenuse on the bottom. If we simplify that, 6 over 10 is what, Mr. Perkins? 3 over 5. He was ready. He was ready. And then tangent I'm going to do down here because I'm running out of room. Darn you fractions. Tangent is the what over the what, everybody? The opposite over the adjacent. What's our opposite, Morgan?
8.
And our adjacent, everyone, is 6. 8 over 6 simplifies to 4 over 3 because we can divide both by 2. So we have 4 over 3, 3 over 5, and 4 over 5. Sine, cosine, and tangent. You don't have to simplify them. I'm not picky about that. As long as you can show me the relationship, that's what these things are. If this was algebra, simplify. All right. Sorry. I'm sure it sounded like on YouTube that I just like smacked my student.
Thinking about something else.
Right. I didn't actually hit her, YouTube. I didn't. It was just a coincidence. All right. Kenny? Oh, Kenny, come on. 2019, man. New year, new you. Go ahead. This is your one. This is your one. Yeah, but like, don't. Alrighty. Do I want to give you this awful worksheet? I don't think I do. I think we'll save it for tomorrow. It's really not. Oh, you're in the math mood? Nice. Do you hear that? I put someone in the math mood, YouTube. I am a good teacher. All right. What a year it has been so far. All right, so these are all our trig functions. Sine, cosine, and tangent. You understand what they are because you know SOHCAHTOA. Now I'm going to show you something I'm probably going to regret because everyone's feeling great. They're all like, this is easy, no big deal. I'm going to show you something that's going to freak you out a little bit. So what if I told you that the sine of theta is 1 over 2? Okay. All right. So what that means is we have a right triangle with a theta, right? And if the sine of 1 over 2, or I'm sorry, sine of theta is 1 over 2, where do I put the 1 and the 2 over here?
Oh, I hate this.
The opposite is
this one.
here, so that's 1. And then where does the 2 go?
2 goes right here.
It goes in the hypotenuse. Very good. So we have 1 and 2. We don't know what this side is. How can we figure out what that side is?
You have to do that one thing.
Yeah, we do. The most famous theorem in all of mathematics. Pythagorean theorem.
I know how to add the water. Don't you do like,
1 squared plus we don't know squared equals 2 squared. Right?
Yeah.
What's 1 squared, everybody? Juan. X squared is x squared. And 2 squared is?
4.
How do we solve a problem like Maria? How do we get x on its own?
What does that mean? Subtract. No.
We're going to have to watch Sound of Music in here. We subtract 1 from both sides. Very good, Morgan. We will eventually square root, but we want to save that. What's 4 minus 1? 3. And x is going to be the root of 3 when we root both sides. So right here is root 3. Exciting, exciting, exciting.
That was pretty exciting.
Now, that's not the bad part. The bad part is what if I said, hey, what's that angle? What is theta?
I don't know, variable.
It's a variable. So what if I said find the value of theta? You wouldn't know, but there's a way to find
Well,
out.
we got a 90 and then we got
There's a way to find out. Now, over here, when we wanted to solve for x, right, we set up an equation, and then we got everything except x on its own, right?
Yeah.
Right, I should say we got everything moved across and then got x on its own, right? So to find out what theta is, we have our equation. We need to get theta on its own. Well, over here we subtracted 1, right? And then we rooted it, right? Those are the opposites of squaring and adding, right? We did the opposite. We subtracted here, we rooted here, and it got us our answer. We undid stuff. So the question is, how do we undo sine? How do we undo sine?
Well, so, oh, I get it. So if it's 1 over 2, right?
Yeah.
You just 2 over 1.
Sort of. We'll talk. All right, so if I told you we were doing addition, what's the opposite of addition? Subtraction. And if we were doing multiplication, what's the opposite of multiplication? Division. And if I was doing squaring something, I'm going to use a squared. What would I do to a? I would square root it. So I would root a, right? They're opposites. Now I've got trig functions, right? All of this stuff is elementary math or middle school math, right? You've done squares, you've done roots, you've done root times, multiply, divide, add, subtract. Now we're going to add on trig functions. And here's how they work. If we have sine, the undo of sine is sine inverse. Sine to the negative first power. All this means right here is inverse sine. There's also another name for it as well that we'll talk about later. It's just the undo. That's all that means. It looks really weird, but that's all it means. Remember when I first showed you theta? And you're like, oh God, what is that? Oh, it's an angle measure. Okay, that's not bad. Remember when I first showed you sine, cosine, and tangent? Oh God, I don't know what those are. How do I translate that?
Yeah, so.
It's easy. Opposite over hypotenuse. SOHCAHTOA, right? There's a way to do it. All this is, it looks awful, but all it is just the undo of sine. So before, when we had this going on, like x over 3 equals 2 over 5, how do we get x on its own? What do we do to get rid of that divide by 3? Multiply by 3 to both sides, right? And it goes away, and we get x equals whatever this is, right? Yes. So we did undo. We undid what was bothering x, right? And we got x on its own, and then we got some answer, right? That's going to be 6 over 5. So how do we get theta on its own? Well, let me give you an example. I've got sine of theta equals a half. So I don't want to bother the half, because half's already on the other side. I want to get rid of the sign. I want to get theta equals a number. So I want theta on its own. I need to do this. Sine inverse of sine theta. And I do it to both sides, because Kenny isn't here. But if I do it to both sides, it's fine, right?
I'm the chosen one.
He is the chosen one, A. So again, to write this more clearly, here's what I did. I took the original problem, which is in red, and I did this to it. I did sine inverse to it. And what happens when sine inverse does something to sine? It goes away. Because they are inverse operations. They undo each other, like multiplication, division, addition, and subtraction. And we get theta equals whatever the sine inverse is of a half.
We have one problem here. We have one problem with this.
Say it again.
We only have one problem with all of this. There's an anime called 7 Deadly Sins. It's my favorite thing to tell.
Oh my
God.
Oh, no.
No
anime. No anime. No anime.
And we
All right.
always think back now, and it's all your fault.
Hooray.
This is my class.
Referencing. All right, so that's all it is. You do it to both sides. You do sine inverse to both sides. What is sine inverse? Don't worry about it right now. It's just what you do. What is theta? It's whatever the sine inverse of a half is. I don't know. Get out a calculator. There's a button for that. It's going to be some weird decimal probably, right?
Okay, Mr. Mack, what was that one thing you were talking about earlier with the person who can't say no to anything? Or ask
Ella Enchanted.
Okay, they need to make like a remake of that.
They did.
Like, she finds love, but she's already in for like 3 life sentences, so she's got to cope with it.
Life sentences? What?
And
In
she
jail?
finds it- She finds her love in prison, so she's like, well, I've got my free will now, but I'm in prison, so what do I do? She's just got to live with it.
That is quite the philosophical conundrum. Now that she has free will, but then she's in jail. Wow. That's an interesting take.
How does she cope with this? Is the question.
This is why you need to be a director and a writer.
I think it's like a wonder.
My brain hurts.
So if I had the cosine of theta equals a half, and I won't use yellow after this, how would I get theta on its own? What do you think I need to do? Sine inverse, right? So cosine inverse, right? To both sides. When I do that, they go away, and I get theta equals cosine inverse of a half. They just undo each other. It's just something you got to know. Okay? You don't need to understand why, because there's no y behind it. It's just what we call that operation, right? If I say multiply 3 times 2, you might say, well, why is 3 times 2 6? That makes sense. But you don't need to say, like, wait, why is times called times? Just because we called it that. We call this cosine inverse. It's the undo of cosine. That's it. They're just opposites, like division and multiplication. Okay? So if I have tangent theta equals a half, what do I need to do to get theta on its own, everybody? Tangent inverse to both sides. It does sound gross. It makes you sound really smart when you say it, right? I'm going to take tangent inverse of both sides.
I just have to do tangent inverse times.
If you want to call it something else, I will say this. There's another word for this. I'll show it to you in a second. This goes the way we get theta equals whatever tangent inverse of a half is, which you could then plug into your calculator and get a number. Okay? And that would be the angle measure. So by finding the sides of the triangle, we can know the angles inside it.
26.565.
Oh, look at you. Look at you. All right. So the opposite of sine is sine inverse. The opposite of cosine is cosine inverse. The opposite of tangent is tangent inverse. There's another name for these. Arctan, arc sine, or I'm sorry, arc cosine. I'll do that in orange. And arc sine. So tan, cosine, oh, sorry, you can't see them. Tangent, cosine, and sine have their opposites. Arc tan, arc cosine, and arc sine. Another way to say it is tangent inverse or sine inverse, whatever you prefer. Okay? It's just another name for it. We're just learning names today. So if you want to go back and review some of this vocab that we learned today, this video would be excellent. I might be able to post what are they called? The Quizlets, if you want to study those. That worked so well last time. Those are the things. They undo each other. Now, Morgan has already figured out on her calculator that you can type in these things and get exact numbers. So that's kind of nice. So I'm going to show you in a calculator what that looks like, just so you're familiar with what's going on. I say that, and then I remember that I just moved all my calculators. You don't remember what they are.
I have a fancy calculator.
I'm going to show you on this one that's not so fancy.
Your boy's broke, so you might not. It's good.
I have a really fancy one, but you don't need that to do this type of stuff.
They told us we would need that.
There we go.
Bro, and they lied.
So my general idea is that, look, why add on a last step of, hey, now plug it in your calculator? Because 9 times out of 10, you're going to plug it in wrong, right? That's the only mistake you could make if you did everything right up to that point, right? You just plug it in wrong. And I don't want to mark you down for plugging in your calculator incorrectly. That's not something I want to do. Should I do it? Yes, because it's important to know how to plug these things in. But it's not my main concern. So most of the time when I say, hey, find what theta is, you can just write, oh, look, theta is this, right? Plug it into your own dumb calculator, Mr. Mac. You can figure it out, right? So if I want to find what theta is, I would need to know the sine inverse of a half. Well, here on my calculator, I have buttons. I have sine, cosine, and tangent. Does everybody see them? I don't want those. I want the inverse. I want the things above them. Yeah. I want the inverse, sine inverse, cosine inverse, tangent inverse. See those in yellow? So what I would do is I want to know the sine inverse of a half. So I would plug in I would do sine inverse. Oh, maybe I wouldn't. Maybe I'd do 0.5 first. Why is this not working? Calculator? Hello? Hello?
Here.
Wonderful.
Here, wait.
You have the same model,
I know.
but it works.
I mean, for mine, I have to do this.
This is the other reason why I don't like demanding that you guys have calculators.
It's working.
Is it really?
Yeah.
Okay, thank you very much. Yep, same one. All right. Yeah, I'm pushing buttons and it's working. Okay, so what you would do, I know, amazing, right? So what you would do, let me zoom out a little bit, is you would type in second sine inverse, and that would pop up. Everybody cool with that? And then type in 1 over 2 or 0.5.
Thing on there?
Yep.
Whoa.
And then hit enter. So the angle measure is 30 degrees. So that's kind of cool.
Where's that button?
So theta is 30 degrees in this case.
Where's the button?
The button, second sine. So second sine inverse. It's kind of hard to see on here because it's blue.
That's how it's the negative.
Does everybody see the sine inverse, cosine inverse, tangent inverse?
Yeah.
Okay, cool. They're kind of hard to see. So the sine inverse of a half is 30. So 30 degrees.
Oh, that's kind of cool because if it's a right triangle.
Yeah. So check it out. Alex just realized what this means. If this is our right triangle and that's theta, we already said that the opposite is 1, hypotenuse is 2, right? Cool. And we just found out that this angle right here is 30 degrees. So what's this angle going to be up here? This angle. This is 30.
That's 90 on the other side.
This is 90. So this has to be What do the interior angles of a triangle add up to? 180. So we have 90 and 30. That makes 120. So what is this going to be? 60. Now, pretend we didn't know this one. What if we just got this? Cosine of negative a half. I'm sorry, inverse cosine of a half. Let's find out what this is. You think so? You think so? So we're going to do inverse cosine. Well, I'm going to try to. Inverse cosine of 0.5. 60. Ah, you were right, Morgan. You were right. And does that make sense? It says the cosine of this angle is a half, meaning that if this angle's right here, 1 is now down here and 2 is up there. Oh, sorry. If we're talking about this same angle, the 1 has to go down here now because it's the cosine is a half, right? Cosine is a half. So that means this angle must be 60 now, and this one is 30. Let's find the tangent of a half. What do you think tangent of a half is going to be? Inverse tangent of a half, I should say. Theta is going to be equal to 90 is a great guess. Inverse tangent of 0.5. Oh man, what happened?
That was the one I sent out to you earlier.
So check it out, check it out. If I have a triangle, and I told you, let me zoom out, and I told you that the tangent of that angle is a half, right? Well, tangent is what over what? SOHCAHTOA. Opposite over adjacent. So the opposite is 1, adjacent is 2. So we've got 1 and 2 here. We know this is right angle. This side length is going to be 1 squared plus 2 squared rooted. What's 1 squared? 1. What's 2 squared? Add them together, you get 5. What's the root of 5? Well, it's just the root of 5. So we get this weird triangle. This is not a 60, 30, 90 triangle. It's not a nice triangle like this guy. We get this. So theta is going to be a really weird angle. 26.56, blah, blah, blah. Do you see how sometimes you can get a really awful answer for these things? And most of the time you will. There are only certain triangles that have really nice angle measures.
I like to just start off from 0 and keep going up until
Yeah. All right, so I said I wouldn't give you this, but I'm going to give it you just to take a look at. We'll work through this tomorrow. I want you to try and get a head start. This is 13-1. It asks you to write out the ratio. It says tangent of angle x. There's angle x. Is what over what? Well, it's wx on the bottom. Tangent is opposite over adjacent, right? So the opposite is VW, like Volkswagen. VW over WX. And that should be the same thing as another angle relationship. It should be the same thing as ZX on the bottom to YZ. It also asks about inverse of tangent. It says find the angle measure here. What would that be? It says VW right here, over WX right here. What's the angle of this? What's the angle measure here? What would that be? And that's what they want you to write. Okay. I want you to guys take a calculator to this part right here. Try some of this out. It's going to be a little weird. We're going to talk about this tomorrow. I just want to get it out to you now. I'm also going to give you this one, 13-2, which I think is a little bit easier. It's asking very similar things. It asks about the Pythagorean theorem, and it asks about sine and cosine, which I think you guys like better than tangent. It's weird how they started with tangent. I'm not sure why they chose to do that in this book. But again, I ask questions like that every day when it comes to this book. So I'm going to turn this off. You can watch the video online if you want some more help. And here will be your